problem called sum of left leaves. So the problem statement is very similar, very straightforward, and it says find the sum of all the left leaves in a given binary tree, and that's it. That's it. That's all about the problem. And this problem was asked in the interview of Facebook and Bloomberg, and this is pretty much simple. Looks pretty simple, but let's have a look at it and understand what's the requirement for us. So let's take this example given this very simple binary tree, and binary tree is one which where every node has two children, two basically two child nodes. And so as you can see, there's a left node and there is a right node, and this is the root. So here we have to just find the left leaves, and leaf is a node which has no children. So here 9, 15 and 7 are the leaf nodes, and the left leaf nodes are the left childs basically. And so basically left leaves are left child as well as a leaf node. So 9 and 15 are the left leaf nodes here, and the sum of them would be 9 and 15. So that's it, pretty much straightforward. And what we need to come up with an approach that is optimal, but I don't think there is. So what we could do is iterate over the entire tree and just check if basically if we have a left child. So for example, let's take a simple example. Let's take this one. We are at 3. We can just check if 9 is there or not. So basically if a left child is there or not, and if this left child satisfies the criteria of being a leaf node, we just count it in our some kind of total, some kind of variable. We just sum it in, and we then keep on iterating. We go on to 9, and 9 has no left children, so we just go back, and it's simple recursion, right? So we go back to 20, and from 20 we go back to 15, and 15 satisfies the criteria, is the left children, and it's a leaf node. So we count it in. So 9 plus 15 we get 24, and then we go back to 20 and we iterate back to 7, but 7 is the right child, so we do not count that. Pretty much simple. So let us jump into the code and let's see how fast we can code this out. We'll use Python for now, and let's take a simple variable. Let's say it's sum of nodes. So yeah, I am pretty bad at naming variables, and we should work on that. So yeah, naming variables are very important when you're basically go- going into an interview, because they very well, they check it very well if you have proper naming or not, and you should be very clear about what you're naming variables on, and how you're naming them, right? So okay, so we took a variable, and then this variable will store the sum. Now what we need to do is we have given this root node. We'll just check if the root node is not null. So basically if this is not none, so another way we could do it is just simply not root, but let's do it in a bit verbose manner. And so we know that root is there, right? uh, so okay, right. So what we're gonna do is we'll be checking if there is a left node of that root, right? So if root dot left is there, and if root dot left is there, so we'll just check if this is a leaf. So how do you check if it is a leaf or not? So we'll write a separate method, or you can just directly do it. So let's directly do it, but we'll follow cleanliness of code and more better verbosity of code. So we'll write a separate helper method to check if a node is a leaf. So if node, so basically just return not node dot left, not node. So I hope you guys understood this. So basically I'm just checking if there is no left children and no right children of the given node, then it's a leaf node. Cool. So I'll just do if this is leaf. So if that basically if the left children is a leaf node, that's it. So we'll just add it. So basically sum of left leaves, and we just add the value of left node. Otherwise, if it's not a leaf node, we just iterate over it. So we'll just keep on adding the value, because this is a problem, right? And we'll just recurse, and whatever value we get it, we'll take it from that, right? So we'll iterate over it. Since this is not a leaf node, basically I don't know you're able to see my comment or not, so I'll just remove it for now. And if it's so basically what we do, if the left child is a leaf node, we add it. If the left child is not a leaf node, we recurse down, right? Because we'll be adding only the leaf nodes. And once that is done, we have to also iterate over the right children. So just keep on doing that. And sum of left leaves, so just go on to the right side, right children, and that's it. By the time we'll be done, so we can just simply return the sum of left leaves. That's it. So let us try submitting this solution. And so we have got an error here. Okay, so that this is coming up due to bad naming again. So you can see this method name and this variable name are same. So let's just name it result, or um, result, or something like that. It's gonna be much similar, but not so good actually. But let's keep it this for now. So I hope this will be it. Yeah. Um, there's no attribute sum of the. Oh my god, I'm sorry. That was not the solution actually. I did not read it. So always read properly. I'm sorry. So I had a typo here. That's it. I guess we should be, yeah, we are done. So I'll just submit the solution, and I'll see if it passes all the test cases. We'll get an acceptance. Yeah. So we got an accepted here, and yes, as you can see that we are our code is pretty much good, and that's it. So that's it for this video. I hope you guys enjoyed it. Do like and subscribe if you enjoyed and find it helpful. See you again. Have a nice day.